Hello and welcome. We are in the run-up to the Excel World Championship Finals in Las Vegas. Less than a month to go now, and so I and lots of others have been spending more and more time on the Excel Esports online platform. And one of the fun things about this is that it has prompted me to revisit some old cases, many of which I haven't looked at for years, including one that I'm going to talk about in today's video, which is Where's Wally? So just for a little bit of history, first, this was the original Dim versus Liana battle, which I won, by the way. There was a time when I could beat Liana, even though it has passed. Um, this was the final score out of like it was meant to be 1,000. It was actually 1,030 by a slight mistake. But anyway, out of 1,000, I got 220. Liana got 160. Um, like we didn't even scratch the surface of this in 30 minutes. And then about a year later, older and wiser, I put out a video on this. Where I went through like a pretty decent solution, but it was a 43-minute long video, and the general approach for the levels was like not bad, but it involved a massive data table, tons of helper cells and stuff, and then for the last level, so the first four levels are various. First it's just you have to find. It's all about a word search, and first it's just you have to find words reading, left to right, and then you have to read from top to bottom, and then you have to read from right to left and bottom to top, and then you have to factor in all the different diagonal directions. And then for the last level, it can snake around, so you might have something like, from this M to U to C to F to M to E to H to A to J to G to Q to whatever, which is a whole other thing. And for that, I came up with this like crazy recursive lambda that I had to call on every single cell. So like 20,000 recursive lambda calls for each answer, and it all worked. But looking back on it now, with the sort of tools we have available now, it seems, even though it was only a few years ago, and even though like it was pretty cutting edge stuff at the time, it seems almost primitive. And so yesterday I was playing a couple of practice games, and someone suggested this case, and we played it. And it was just really interesting to me to see how different it looked today. And so I thought I would make a video on that. So here we go. So I'll start my own timer, and we'll download the file. Yeah, see, it's Where's Wally 1 because I just did it yesterday. So again, just to kind of quickly go over it, we've got this thing. It's called the maze. It's 1,000 rows by 20 columns. And there are wildcards in it, so this question mark can stand for any letter. So this first thing here matches Wally as the example. And all the answers are what address does the word start in, which can be any of the 20,000 addresses in the grid. And so for level 1, words can only read left to right. If you find the same word pointing right to left, it won't count. For level 2, left to right or top to bottom. For level 3, any horizontal or vertical direction. For level 4, any horizontal, vertical, or diagonal direction. And then for level 5, there are only 3 words, but each letter could be adjacent to the previous letter horizontally or vertically in any direction. So let's dive on into it. The first thing I'm going to do, just so that I can do it with one array formula, is I'm just going to actually, I don't even want to paste them. I want to just want to flatten all these out with one without the spaces, because these are, again, this is like early FMWC stuff. There's like lots of merged cells, so I'm just going to do them over here. Okay, so the way that I'm going to think about this is kind of more, the way we think about mazes now, which is, for any given starting cell, there are 8 different directions you can go off from that, meaning, you can go off this way, or this way, or this way, or this way, or the 4 different diagonals. And if any one of those starts with, like, let's say it's FMWC, if the first 4 characters of any one of those matches FMWC, then it's FMWC and we're away, and otherwise it's not, obviously. So actually, let me just come over here and name this grid. So the first thing you might want to do reasonably is to call grid. I'm going to import my lambdas because the kind of thing that, again, is much easier to do with lambdas. So I have a lambda that just gives me the addresses of cells. You could equally do this by saying, address of row of grid and column, but anyway, I'm not doing that now. And actually, sorry, I don't, yeah, I suppose I want the addresses and I want the row column references, so let's do that as well. And if you watch my channel, you probably know by now the way I do row column references, 1,000,000 times the row number, so in this case 13 million, plus the column number, so 13,000,002 is the row column reference for a cell. And the reason that I do it like that is because it makes offsets all one-dimensional. So I have my arrow offset codes for the 8 possible directions you can move in. So, if you subtract 1, that's the equivalent to taking a step to the left. If you add 1, it's the equivalent to taking a step to the right. If you subtract 1,000,000, it's the equivalent of taking a step up a row, adding 1,000,000 is down a row, and then all these combinations of those correspond to the 4 different diagonals. Now in this case, I guess I want my arrow offset codes to be slightly differently ordered, just to reflect, because I'm going to do this all in one go, and because potentially these could have multiple matches, I want it to be that the matches come in the sort of order of priority. So I want my left to right first, then my top to bottom, then the other horizontals, then the diagonal. So I'm just going to copy value paste that. So my left to right will be that one comes first, then my top to bottom, which will be adding 1,000,000, then my other horizontal and vertical, and then my diagonals. I also want it to be across a row, so we'll do that, and we'll just take that, and yeah, I'm going to just save that as a name. So say new, call it dirs equals that, just as an array constant. And so now, where can I get to from W is just, or where can I get to from anywhere, but let's start with W, is just that plus dirs. So these are the row column references of the 8 different places that I could get to from there. So in other words, if I go, take a step to the right from there, then I'm still in row 13, which is the 13,000,000, but now I'm in column 3. If I take a step down, I'm in row 14 for the 14,000,000 and column 2 and so on. But I don't want to just take one step. I want to take more steps, and specifically, let's just see what's the max len of these. I want to take up to 12 steps starting from 0. So we're going to say dirs times sequence of 12 starting at 0. So now, basically in all 8 directions, so here's me stepping to the right. So I go 13,000,002, 13,000,003, 13,000,004, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then the same thing if I'm stepping down the rows, I go 13,000,002, 14,000,002, 15,000,002, 16,000,002, and so on. And then for each of those, I can say 2ref of that on grid. Now my out of bounds character is an X by default, which is not helpful here because that could be a letter. So I'm going to change my out of bounds to, I guess, just a blank. So this is what I get if I read across from there. WA question mark LY SS TROPS etc. And then I can bycall concat that, and that will give me all of those. And then I can use by row, which will allow me to operate by row, but also return an array of values on this whole array. I'm going to say lambda row bycall and just replace that row with that, and that. No, sorry, that's just calculating, that's okay. There are 20,000 cells in this thing, so it is not unreasonable for this to take a moment. I must say this is taking a little longer than I wanted it to. I remember this going faster when I did it. Maybe I did some subtle difference that made it more efficient. Oops. Yeah, that's definitely going slower than it was before. The only thing I remember being different is that I didn't use 2ref, I did an XLOOKUP. I would have thought the way my 2ref works that it would be at least as fast, but okay, let's try it just in case. So what I did was a binary XLOOKUP, which is also quite fast, but shouldn't be that much faster. So we're going to look up on this list of row column references and return from this list of cell values. And if not found, it's going to be that blank just as before. But then I also want to use search mode, binary search, much faster because it's sorted in ascending order. But I don't expect that to be enormously. Oh, okay, that is enormously faster. That's weird. That is a sign that maybe my 2ref is not as efficient as I want it to be. But okay, that's fine. So that gives me that, and then I just want to call this, and yeah, I want it. So what I want to do is I want to call it reading down the columns because I want all the left to rights to be matches before any of the top to bottoms, and then so on. So we're going to call all of that reading by column, and then we're going to flatten where that is not blank. I want this, so just to repeat the addresses, the apt number of times. So then these are, oh wait, no. Sorry, that's because this also needs to go by call. There we go. So these are all the left to right reading ones, and then so on. I guess I could, no, never mind, doesn't matter. So now that I've done that, I should just be able to XLOOKUP all of this and star, in other words, anything starting with that, in this list of all the partial matches in every direction from every starting location, returning from the corresponding list of starting locations, and I want wildcard character match. Oh, right, I have not yet dealt with the couple of things that have the wildcard issue, which this technique might need some adjusting to deal with. But that gets you most of that. Is there a way for this to deal with that? I guess there's nothing desperately efficient. One option would be to do a countif on each one of these for that. Sorry, on that for each one of those. So, am I doing this right around? I think I am. So if I said countifs, this is that. Sorry, that. I guess we need to be left this len of that. And sure enough, that does give one match. Okay. So I guess that means I'm going to have to unarray it. So just get rid of that. And then we'll say if not found. Just write it as an if error because I find that more straightforward to understand. So then it's going to be XLOOKUP1 in countifs that, left that len of that, and return from these addresses. Except now I have to lock a bunch of stuff because I'm not doing it all by array. So lock that and that and that and that. And that then handles the space and wildcard neatly, I think. Yes, happy days. All right, so now we got to deal with the snake, which is the more complicated part. But again, which is very much up the street of the modern maze approach. So let's say I have snake, then what I want to do is think about all, first I want to think about all the starting positions. So I'm going to do it by the row column reference, because then I can add to it to get the offsets. So I'm going to think about all the starting positions where the character is equal to left of this word, and there they all are. And then from each starting position, I can say this plus deers, except I don't want all the deers. I only want the first 4 directions, because that's the up, down, left, right, and the snake can only go up, down, left, or right. And then I want to say XLOOKUP that in here, lock return. Oh, wait, why was that not dynamic array? Was I pointing to the right one? This one should be a dynamic array. Right? EN15 hash. Okay. Don't know why I didn't turn that into a dynamic array, but never mind. And then return from, get out of my way. Don't get out of my way, from AKLAL 15 hash. With a binary search. And so that gives me SUY and not found, and I'll make my not founds be blank. And then I want to say let A be that, and then I want A equals mid of this to 1. In other words, A is the second character of that, or A equals question mark, because that's my wildcard. I don't think any of the snakes actually required a wildcard, but they could have. So, sorry, then let's call this NXT-RC, next RC, and make that its own name. So then we're going to say if that condition is met, then I want NXT-RC, otherwise blank. And these are all blank. And then I want to join those together with, let's say, just a comma as the separator. And that gives me nothing. And sorry, actually, not quite, because I want to be able to make this. So instead of just pointing at that, I want to be able to point at the whole reference. And now we can see there are some that do have a next move next to it, including at least one that has multiple next moves next to it. So then I want to operate by row, so that this all remains dynamic. Lambda row text join with a comma, the row. Okay, so these are all the first places where I could get an S, and then these are all the places next to those that I could get an N. And now we're almost somewhere. So then what I want to do is first stack these together. And then I want to filter to only the ones that have a valid second move, so where this is not equal to blank. And that's great. But then to be able to kind of go on with it, to be able to do a next step similar to the step that I just did, I need these ones split out. Now you could do a kind of bi-row operation for that, but as it happens, I have, thanks to JJ, Juan Jose Fuentes, this cool idea of an unsplivet lambda, a mixture of text split and unpivot, which does exactly that. Interesting, I guess I have an if, like a try converting it into a number built in there, which I don't remember doing, but anyway, that's fine. It would have worked anyway. So then I can unsplit it, and now I've got, these are all the possible starting points, including a repeat if necessary, like here, and then all the second points that you can get to, and then I just need to keep repeating that logic to get to, from each of these, what are the third points I can get to, and do those match the third letter, and so on. And so now we have the idea. Let's try and build it. So, let's see, I need this. I'll copy that, and I need this. So I'll paste that and that, bring them both over here, and then let's build it. So I want to reduce from here my I'm going to need to take, so if this is a 5-character word, these are all the things after 1 step, so then I need to take 4 more steps. So in general, it's going to be sequence of len of this minus 1 starting from 2. So in other words, now I'm looking for the second letter, third, fourth, and fifth. We'll go with that. So then I want lambda, I'll call it cans for candidates and num for letter number. And then we go here. So let next RC is going to be, I want to, so it started off with just being cans, as in take the candidates, but as I stack them together to make more, it's going to be take candidates last column, plus the directions, that's good. Then we look up that to get the letter, and these are just fixed values, that's fine. We do the by row operation, again, this is just a fixed location, so that's fine. And we're saying, is it equal to the next letter? Oh, sorry, that 2 becomes num. That's important. Or a question mark, that's good. Then we join them. So then I guess this is, call that letters, just to be slightly better about naming. So do that. Bump that in, bump this in. Then we will call this, what is this? This is NXT steps. Good enough. And then we get on to this next one, which was unsplit filter hstack. So we're going to stack the old candidates next to the next steps. No, sorry, the next steps. Oh, that's not auto-completing, which means I've got the brackets wrong. Yes, that's wrong. There we go. Hstack that with next steps, where next steps is not equal to blank. Unsplit it by that. And if this works first time, I'll feel pretty good about myself. And we got some spill errors, which is fine. And there it is. And so then we just want to take the first one of that. So this is saying, this is where you get the S, the N, the A, the K, and the E, and there's only one possibility, and the other words are winner and difficult. And yeah, in both cases, there's like with winner, I think there's like 2 different I's you can take. You can go from like a W to an I here or an I here and then onward. Or no, it's not. Well, anyway, it doesn't matter. But it's the same starting letter. So in each case, I'm just going to say take at to get the first one and to add to convert it to an address. And that should be the answer that we're actually looking for. So I'm going to take all that, cut it, bring it down here, and then just want to, oh, I made a few different references to that cell. Actually, that wasn't smart. I'll have to change that in a couple of places. Just 2? Yeah, just 2. Oh dear. How on earth did moving it over there break it? Really, did I? Oh yeah, I did. I missed another reference. Thank you. There we go. Oh yeah, and then I didn't lock things because I was doing everything dynamically. Oops. Slightly anticlimactic finish there, but never mind. Shazam. So yeah, just thought that would be a fun one to play with because, like I said, it is fascinating for me to see, in a sense, how far we have come. That, like, not just, I can solve this quicker. Obviously, I can solve it quicker than I could live seeing it for the first time 4 years ago because I just played it yesterday. And I played it yesterday having, remembered it from 4 years ago and remembered it from doing a clean solve of it after and blah, 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 blah. But like the change in the methods, like, the approachability of this compared to the recursive lambda method and the speed of it compared to the recursive lambda method. This honestly feels, still a little bit clunky, but it's also not hard for me to see how you could very easily just take all of this and this and this and this and this and this and just kind of smash them into one single formula that would output all of these without all of these spilled out here as workings. But anyway, I'm not going to make you watch me do that because it's not desperately exciting viewing. The point is, that it's all just so much more possible now, which I think is pretty cool. Anyway, that's enough yak. That's all I got for now. Thanks for watching. See you next time.